Alright guys, I'm going to make a really quick review video for you guys. So let's go ahead and get started. I just needed to make sure that I am recording, and sure enough I am. So right here, down this entire left column, it starts with shift functions 1 through 6, so that's numbers 1 through 6 all the way down this column. They will shift them up 5, vertically shift up 5, horizontally shift left 3, and vertically stretch by a factor of 2. So remember, all that stuff is based on this idea right here, where K moves it up and down, H moves it left and right, but it has the opposite effect. It's a negative H. And A will stretch it, compress it, or flip it upside down, or reflect it. What I mean is reflect over the x-axis. So right here with x squared, if I'm going to shift it up 5, left 3, and stretch it by a factor of 2, then it's going to have to look like this. Left 3 and up 5. Okay, so there it is. Stretch by a factor of 2, which is this last one. Left 3, so remember H has the opposite effect because of that negative sign right there. And up 5. So let's do it again right here. Stretch by a factor of 2. Left 3. Up 5. So there's the next one. Notice it looks almost the exact same as the quadratic function, except it's a cubic. So there's a 3 here, which I almost made a mistake on, instead of a 2. It's to the 3rd degree. Square root function, same exact idea. And the whole point of this worksheet is so you guys see that you can shift any function, and it's always the same idea behind it. So whatever's multiplying right here, the A is going to stretch, compress, or reflect it. That's going to shift it left 3. That's going to go up 5. Notice all these look very similar. Other than there's a square root function, it has a square root. There's a cubic function, it has the cubed. That's a squared function, or a quadratic function. So notice this is going to be an absolute function, but it's still going to have the 2 out here. Absolute value plus 3, absolute value plus 5, just like that. There it is. All these functions, again, have these parameter changes. Vertical shift up 5, left 3, stretch by a factor of 2. Now this is going to be an interesting one. If I really wanted to cheat my way through this, I could just kind of do it like this. Plus 3 and up 5. Now the linear function is a little bit different, so that's what it would look like. But the linear function is different in that there's no need for these parentheses really. So I could address that later in class if you need, but really that's not going to make much of a difference. So let's go ahead and go on to this one. So stretch by a factor of 2. This one's kind of interesting right here. 1 over x plus 3. These rational functions are always kind of difficult. Plus 5, something like that. But that 2, when it gets distributed into here, it's just going to be on top. So it's going to look like this, actually. 2 over x plus 3 plus 5. Like that. So this is the one we're looking at. And if you're concerned with that number on the top, it's a 2. Bad handwriting. Okay, so this is the same idea. I'm not going to do all of these. I'm just going to do a few. But vertical shift down 3. Horizontal shift right 2. Compress by a factor of 1/2. So if it's compressed by a factor of 1/2, notice these are already located somewhere other than the parent function. It's a quadratic parent function though. But from where it's at already, I'm going to shift further right 2. So I'm going to do right 2 from here. It's already right 3, so now it's going to be right 5. I need to go down 3. Well, it's already up 1. So if I went down 3 from there, it would be at minus 2. And compressed by a factor of 1/2. So let's just put a 1/2 in front of there. Simple as that. Okay, next one. So I need to go down 3. So it's already down 1, so it's going to be a down 4. I need to go right 2. It's already left 1, so if I go right 2, it's going to actually like something like this, x minus 1. So I'm going right 2 from here. It's already left 1, so I need to go right 1 would be at 0, then right 2 would be at positive 1. So how do I get to positive 1? Remember, h is an opposite. Okay. So next, compress by a factor of 1/2. Just like that. Let's do this one real quick, and then I'm going to move on. So I need to shift down 3, so it's already up 3. So when I go down 3, that's just gone. It's not even there anymore. Horizontally shift right 2. It's already left 3, so I need to go right 2 more from there. So then it's going to end up looking like that. And y equals something like that. Oh, compressed by a factor of 1/2, sorry. It needs to have the 1/2 in front. Okay, so as far as transformations are concerned, I think I'm going to stop there. Sure, I'm going to go ahead and graph one of these real quick. So graph the inverse squared parent function from number 12 and its translation. Well, here's the inverse squared parent function. Like something like that. And what's the transformation? Vertical shift down 3. Vertical shift down 3. And give me a second. So if I go down 3 from here, it's going to look like this. Down 3. And then right 2, so I'm going to have a minus 2 in here. And then there's also a vertical compression of 1/2. Now I don't expect everybody to get this totally right, but pretty much it's just going to be wider than it was before. And that's the main thing I want to get out of this. That's a terrible graph.